is Geometry Day 2. Alright, so the first thing is quadrilaterals, which just means a four-sided figure. And just a couple of facts about them. They have a total of 360 degrees inside. So this is showing you the measures of these four angles. And if you added those up, they would add up to 360. The perimeter, you just add up all the sides. And then there are special types of quadrilaterals. The first one is a parallelogram. And you have two pairs of parallel lines. And the area is the base times the height. And notice that the height is drawn inside the parallelogram. It can also be drawn out here. But the key is that it has to make a right angle with the base. You can't have this be the height. The height, if you think about it, is when you stand up straight. So if we were to stand up straight, you know, how tall would this be? So the height has to be straight up and down. Rectangles are a special type of parallelogram. They're also a quadrilateral, so we're kind of narrowing it down and getting really specific. We have four right angles. And there's still two pairs of parallel lines, so it's still a parallelogram. And the area is the length times the width. In this case, because you do have a right angle between the sides, then this is the height. You can still do base times height here, but the height now is one of the sides. Note that there's not a relationship between the perimeter of a rectangle and its area. In other words, two rectangles can have the same perimeter but different areas. So for example, I can have these both have a perimeter of 14. If you add up all the sides. But this one, the area, 5 times 2 is 10. This one, the area, 6 times 1 is 6. So just because two things have the same perimeter doesn't mean they have the same area. Just because two things have the same area doesn't mean they have the same perimeter. There's not a relationship there. And then getting even more specific, squares are a specific type of a rectangle. They also have four right angles. They also have two pairs of parallel lines. But this time, those lines are all the same length. And so the area is still length times width or base times height. But because those two dimensions are both the same, you can just square one of them. And a lot of times a square problem is not really a square problem at all. It's actually a 45, 45, 90 triangle problem. Because if you cut a square in half diagonally, you create two 45, 45, 90 triangles. So a lot of times that's the rule you're going to use. Okay, so the first quick quiz, quadrilaterals quick quiz. It's quick quiz number 5. And there is an easy, medium, and hard. So we'll take just a few minutes to do those. Yeah, especially if you don't remember some of the rules. Okay. So let's look at the first one, which is pretty straightforward. They have a rectangle, and one side is 10y, and one side is 2y. And they tell you what y is and ask you to find the perimeter. So you just got to plug in and then add up all the sides. So if y is 3, that makes this side 30, and this side 6. And that makes this side 30, and this side 6. And if you add all those up, you should get 72.
If you got that wrong, you shouldn't be taking the test.
Okay. On the second one, what's the area of a square with a diagonal of 5? So this is what we were talking about in the notes. This is an example where it's not really a square problem at all. it's a 45, 45, 90 problem. Because when you divide a square in half, you create two 45, 45, 90 triangles. And what the 45, 45, 90 rule says is this, that the two sides are the same, and the diagonal, or the hypotenuse, is one of those sides times the square root of 2. So if we know that the diagonal is 5, we can divide that by the square root of 2 to get one of the sides. So each of the sides is 5 divided by the square root of 2. And then to find the area, you just multiply those together. So if I multiply 5 divided by the square root of 2 times 5 divided by the square root of 2, I get 25 divided by 2, because 5 times 5 is 25, and the square root of 2 times the square root of 2 is 2, which is 12.5.
Whoa, what? How I did it was the 3, 4, 5 triangle.
That's close. It's not a 3, 4, 5 triangle because these two sides are the same length.
Oh, it has to be 30, 60, 90.
Yeah.
Right?
No, that's still not even a 30, 60, 90. That's just a Pythagorean triple. That's just a special right triangle. But yeah, you get close, right? Because these two sides, 3 and 4, are close, and these two sides are close to being 3. They're between 3 and 4, so it kind of works out. And I heard you saying that, so I was like, he's gonna get lucky with that one.
I still probably would have picked that and probably
Okay.
would not have picked the answer.
Alright, so this one's important because it says the figures aren't drawn to scale. So this looks like a long skinny rectangle, this looks like a square, but that could be completely false. So don't assume just from looking that things are as they appear. So it says the length of rectangle A is 1/3 the length of rectangle B, and the width of A is twice the width of B. What's the ratio of the area of A to the area of B? You should just plug in here, because this is asking for a ratio of unknowns. It's kind of like a percent or a fractional part. So you can just make stuff up. So I'm going to make the length of rectangle A be 2, and that's 1/3 the length of rectangle B, which means the length of rectangle B would be 6. And then if the width of A, I'll make the width of A be 4, is twice the width of B, so that would mean that the width of B would be 2. What's the ratio of the area of A to the area of B? Well, the area of A is 8. The area of B is 12. So 2 to 3. B. Now you could just make stuff up because this is asking you about a ratio or a fractional part of an unknown amount. So when you have that, you can just make stuff up. Just make sure it fits the problem. So plug in. Okay. Alright, so now we are ready for boxes and CADs. You can forget spheres, cones, and other complicated 3D nightmares. Most often on the SAT, if they're going to ask you about something three-dimensional, you'll be asked only to deal with a rectangular solid or a box, a cube, which is just a special kind of rectangular solid, it's a square box, and maybe a cylinder. No matter what the shape is, the volume equals the area of one of the faces times the third dimension or the height. So you just find the area of one of the faces and then multiply it by the other dimension. So, for example, here's the formulas that you will need to know, and I think they give you all of these at the start of the section.
Yeah.
I think they do. So, these are the formulas for a rectangular box. The volume is length times width times height, and the surface area is the sum of the areas of each of the faces. So, you have two faces that are the length by the width, that's the bottom and the top. You have two faces that are the length by the height, that's the two sides. And then two faces that are the width by the height, that's the front and the back. So a total of 6 faces. You just pair up all the dimensions. A cube, the volume is just side cubed because all the dimensions are the same in a cube. And then a cylinder, the area of the base, which is a circle, pi r squared, times the height of the cylinder. If a problem concerns a cone, a pyramid, or any other shape other than the ones that that are described, they're going to give you the formula. If you aren't given a formula, it's because you don't need one. Okay, so you don't have to worry about memorizing any other formulas. Okay, so quick quiz number 6. And I think these all deal with rectangular solids, so these will be pretty easy. Okay. So the first one, if the volumes of the two boxes above are equal, then what is H? So if you look at the first box, you can actually find the volume of this box because they give you all the dimensions. So the volume of this box, 3 times 5 times 4 is 60. This one is also supposed to be 60, so H times 10 times 6 has to equal 60 as well, which means that H has to be 1. Because 1 times 10 times 6 would be 60. Right? That makes sense? Mm-hmm. Okay. The next one, Sam is packing toy blocks into a crate. Each block is a cube with a side of 6 inches, and the crate is 1 foot high, 2 feet long, and 2 feet wide. How many blocks can he fit into the crate? So he's got this crate that's 1 foot by 2 feet by 2 feet, and he's going to pack these little cubes in there that are 6 by 6 by 6 inches. So how many of these will fit into here? So I'm going to change all these dimensions to inches. If you multiply all those together, you'll get the volume of that box,
69.
which is 6912. And if you multiply all these together,
260.
you'll get the volume of one of these cubes. Divide those. 32 of them. Another way to look at it would be, if each of these is 6 inches, then you can fit 4 across here, 4 across here, and 2 here. So 4 by 4 by 2, that's 32. Right? You can also divide before you multiply. You can see how many cubes will fit along the front, the sides, and up to the top. Okay, the surface area of a rectangular solid measuring 5 by 6 by 8 is how much greater? And really they should say how many times greater. No, maybe it is how much greater. How much greater than the surface area of a rectangular solid measuring 3 by 6 by 8. So I think all you have to do here is find the surface areas. So the surface area for the first one, there's going to be 2 sides that are 5 by 6, 2 sides that are 5 by 8, and 2 sides that are 6 by 8. Which would be 2 times 30 plus 2 times 40. Plus 2 times 48. So 60 plus 80 is 140. Plus 96, this is 236. And then the other one, you're going to have 2 that are 3 by 6, 2 that are 3 by 8, and 2 that are 6 by 8. This would be 36 plus 48 plus 96, 180. So that's a difference of 56. What did you think to do?
He just subtracted them all.
Subtracted the numbers and then multiplied them?
No, I multiplied this stuff out and then subtracted.
Well, that would be the difference in their volumes.
Yeah, I know.
Yeah. So, surface area is the key here. Right? Yes. Okay. There's just 2 more. So that's about halfway. I can do the rest of it tomorrow.